you looking for a unique end-to-end data science project that'll spice up your resume? You found it, but from here the choice is yours. You could be like the other 99% of the people that are going to leave the video right about now, or you could be part of the 1% that adds an amazing exploratory data analysis project to your resume, adding PySpark, SQL, data visualization, linear regression, so much more to your resume that will drastically increase your chances at getting an interview at all, as well as give you the skills and confidence necessary to succeed and pass in that interview and get a job. But go ahead, take your pick. Either way, I'll be here explaining the project simply for those that are ready to put in the effort. And honestly, it's not nearly as much work as you think it is, although of course you're going to have to put in some work because good things only come to those that are going to persevere. So fight that urge to run away from your problems. I know that you can do this, and if you think about turning off the video, first consider slowing it down. You can toggle the speed up or down. You can take a quick break. You can pause the video and look things over. You can also always think about me staring you down and saying, if you're going to turn off the video, you probably don't want to do that. Oh, and if right now really isn't the right time to watch the video, that's totally okay. Just make sure that you subscribe so that you can see me staring you down wherever you go. By the way, there's really no prior knowledge assumed in this. It might help if you've seen Python code before and done a couple of these things, but honestly, you could get by with knowing nothing for this. I'll show you how to do everything no matter what, so there's no excuses there. One more thing, if you're just sitting there on your phone watching this right now, just crank up the speed, bump it up to 1.25, 1.5, 1.75, and just watch me go through it. You'll learn a lot without even coding it yourself. You don't have to whip out your computer and do all of this to add it to your project. You can still learn a lot, and it's going to be a very short amount of time if you go through that speed. So just crank it up and watch it and enjoy. But if you want to go through the project, I recommend doing it at the normal speed or maybe even a slower speed. Anyways, I'll see the 1% of you that have got this. For the rest of you that really don't want to do it, well, I would really second guess that, because if this is something that you want, if you want to be a data scientist or analyst and you're not willing to put in the work, please, before you consider doing that and you're still watching me, just watch the video. It'll pay off. I cannot stress enough the importance of utilizing your speed options. If the video is going too quickly, then please slow the video down. If it is going not quickly enough and I'm too boring, please crank up the speed, 1.25, 1.5. You'll learn a lot just by not even following along with the code, writing it yourself, but just watching me code it very quickly, and you'll learn a lot. So please enjoy, and I'll see you in there. We're going to be using the Kaggle latest COVID-19 India statewide data, which was updated just 4 days ago. So it's very up-to-date and interesting data that is actually very important to understand. We're going to start by downloading the dataset. It'll bring a zip file to your computer. I have it here. I actually changed the name to indiacoviddata.zip, and I'm going to upload that to whatever environment you're going to use. I use Google Colab so that everyone can follow along. I just upload the file here, and now we have that dataset. It is a zip file, so to get rid of that, we'll do !unzip and then the name of the dataset. And if we refresh over here, we should see that it has this file right here. Now we're actually going to be using PySpark a little bit today. It's not too complicated, so don't worry if you don't know or have never seen PySpark before. This is going to be a great chance to get hands-on with it. PySpark set up on Google Colab. I have it here, so I can just copy these 3 blocks of code and run each of them. And so I just pasted those in and ran each of the cells. It takes a little bit of time, and then Spark will be available from this thing called Spark right here. And if you don't see this and you got some sort of error, please let me know in the comments and I can try and help you out. So we're going to load it in as a Spark data frame, and so we'll do df is equal to spark.read.csv. We're going to pass the name of the file, which we can just copy and paste by doing this. And we want another argument saying infer schema equals true. And we also want header to equal true because we have a header in the file. Then if we just output df, we should see a very SQL-like table. And if you haven't done SQL before, that's okay. We're going to get used to that as well. So here's our data frame. We have 20 rows, and it has the state or union territory, total cases, active, discharge, deaths, the active ratio as a percent, the discharge ratio as a percent, and the death ratio as a percentage as well. Now what the data set doesn't have is any sort of recollection of the past, so it's just the current cases for each of these different columns. Now, PySpark really doesn't like characters like this slash in the middle, spaces in the middle for sure. Brackets and percentages are not good, so we're going to just make it each column name is the words separated by underscores, so there's only letters. And to do that, don't worry too much about the specific code. I will show you how to do it though. We'll do from PySpark.sql import functions as f, so that renamed df is equal to df.select with the list of f.call of call.alias, which means rename, where we call.replace a space with an underscore. And we'll do that for call in df.columns. So now renamed df didn't get rid of the divide and the percentages, but it did separate each of the spaces by underscores. We're now going to do some manual work to just get rid of the divide as well as the end here for the bracket percentages. We'll do renamed df is equal to renamed df dot with column renamed. We're going to do this function 4 different times, and so we'll replace state slash uts with just state uts. And then we're going to copy this because we're basically just going to do the exact same thing 3 more times, except with this column name. We're going to put that down here and then get rid of the end over here and leave it like that. Now I'm going to do the exact same thing with the next 2. And so I'll just copy that twice, and we'll do, instead of active, we're going to replace it with discharge and to death. And then finally, renamed df is going to have all the right column names, and everything's going to work out better now. Now, I always prefer to do as much SQL syntax as possible. If you're familiar with PySpark and you want to do it a different way, that's totally fine. But I like doing it this way, where we do create or replace temp view, and then we pass the name of the table that we want. And so we're going to call it data. This is our choice of table name, so that now we can just do stuff like spark.sql. For now, I'll just do select star from data. And you'll see that returns the exact same table as above. And you'll see that returns the exact same table as above. Now we can ask many interesting questions about this data set, such as, for example, how many state or UTs there are. Many of you may know the answer to this question, but I didn't beforehand. Many people probably don't. So we'll do spark.sql, select the count of any column, but we'll do count of state UTs, and we'll get that from data. And it's going to say we have 36 states and union territories. Now, I apologize for the dataset being a little bit depressing, but honestly, that's what it is, and very interesting data. So we're going to ask some questions about where it's bad right now. And so right now, that is to do with active. So we'll do select star, except we'll do that from data. We will order it by active, the active number of cases. Actually, we'll do descending for sure, so we'll see the worst places, and then we'll limit it to 5, just to see the 5 worst. Right now, you really don't want to go to these places, and I apologize, I'm not going to even try to pronounce a lot of these. I probably would get them decently close, but I don't want to sound like an idiot. Another interesting question we might want to see is maybe where the healthcare is having trouble, or where the variants are worse. It's kind of hard to say. It's just where in particular COVID is actually worse. Not necessarily more prevalent, as in more people, but actually takes a bigger toll on people, and that is the death ratio. So we'll ask the same question, but do it with death ratio. And so that tells us that it is actually a lot different list from what that is above. Now this one's really sad, but I want to show you the answer to this question. How many people total have gotten infected and how many people have died total? It is going to be select sum of total cases and the sum of deaths. And this answer is a whopping 32 million people, 285,857 people got infected. But luckily only 432,000 have died, which is still a massive number, but luckily it's a lot less than how many actually got infected. On a slightly brighter note, let's look at where we might want to be. And so I'll do the same as above, except we're going to do it sorted by active, and we'll do it by ascending. Okay, so these are the safest places to be right now. It is going to be these 5. Now you can feel free to do more analysis in PySpark on your own if you'd want to, but that's all we're going to do for now. And so we'll do now import pandas as PD and do our analysis in pandas, and actually mostly Plotly. We're going to do a lot of visualizations here. But first, to get it into a pandas data frame, we'll do pddf is equal to, it's very simple. We have data frame above as renamed df, and we're going to do that dot to pandas like this. It should look very similar, except this is an error because I have an extra F there. And now we see it's very similar to the above table, just in a pandas format. Something we very commonly do is describe, so we'll do pddf.describe, and that's going to basically give a bunch of summary statistics that are interesting to us, and I'm not going to read them out to you, but basically nothing too interesting stands out to me. Everything looks pretty clean. Something I really like to look at is the correlation matrix, which basically explains the linear correlation or relationship between the variables. So ignore the diagonal because that's not very useful to us. We can look at something like maybe the discharge ratio, negative 0.98, as one of these variables increases, the other decreases. Discharge ratio and active ratio. And that makes perfect sense because this means how many people have actually left out of the people that got infected, and this is how many people are still active and still have the infection. And so it's going to make sense that as one of these increases, the other is going to decrease. Another very obvious relationship is that the more and more people get the disease or infection, we have more and more deaths involved. Hence, this is a positive value, which means one increases, the other increases, and 0.9 means it's a very strong relationship. as opposed to the other values that have a relationship close to 0. That means from the data we don't see too obvious a relationship. Now this project is going to be very focused on visualization, so we're going to see a lot of Plotly, and it's going to graph many beautiful and honestly very easy to make. You just have to look up how to do it. Graphs. There's three very common Plotly imports, which are import plotly.graph objects as Go, import plotly.express as px, and from plotly.subplots we'll import make subplots. So graph objects is their main graphing part. Plotly Express is a way to make easier graphs. It actually is just really a reference to this. And then make subplots is for making multiple graphs in the same picture. We'll start by making 4 nice histograms on total cases, deaths, active, and discharged. We're going to look at these 4 variables a lot. Now don't worry too much if you don't understand all of the Plotly code. Really it's just look it up and figure out how to do it. You will get better at it over time though. We'll do fig is equal to make subplots. And then how many rows and columns do we want? Well, we want 2 rows and 2 columns. And we'll make the subplot titles equal to the list of above. Now fig right now isn't something very useful. We have to do a lot more for it to actually work. We'll make each 4 of our histograms one at a time. Luckily, they're going to look very similar. So we'll do total cases is equal to go.histogram with x equal to the PDDF, so that's our data frame, where we have total cases. We'll specify the number of bins to be 20, and we're going to set the name of this to be total cases. So essentially what this means is what's going to show up on the x-axis, how many bins for the histogram we're going to have, and the name of it, that's often used for labeling purposes. Now I'm going to copy and paste this 3 more times. 2, 3, 4. I'll make each of these the names, and then we're going to do some very obvious copy and pasting. Wherever we see total cases, we're going to replace that with each of the names. And we'll actually keep this lowercase just to be consistent. And for our histograms, that's actually all we need to do other than just add them to our fig. So we'll do fig.addTrace one at a time and tell it the position as well as which one it is. So we'll add total cases to the position of row and col, which is going to be 1 by 1 to start. And we're going to basically just copy and paste the same thing except with changing the row and col and the name. So we'll put deaths as the second one, active as the third one, discharge as the fourth one, and then we want these 2 to be in the first row except this one to be the second column, and these 2 to be in the second row except this one in the second column. Now we'll do fig.updateLayout, where we don't want to show the legend, and that's as easy as show legend is equal to false, and then we'll do fig.show, and that finally shows us our amazing 4 histograms, and we have total cases, deaths, active, discharged, where each of them shows how many of the union territories or states. And Plotly's fantastic for its hovering ability, as well as zooming. We can click on stuff and show different regions that we want to look at. Now something interesting from the data, we can see they all have the same type of pattern, where most of it is clustered around mostly 0, except then there's a couple that have quite a few more than the other ones do. Now we might be interested in what these outliers are, like what is this point, what is this point, what is this point, and so to do that we'll replace all of these graphs with their box plot instead of a histogram. And so we're going to copy mostly the same data that we have, or the same code that we have above, except make some obvious changes. Histogram is actually going to be changed to something called box, so we're going to change that box, 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 box. We're going to keep x to be the exact same thing every time. We will get rid of this number of bins thing, but we are going to add in the exact same thing for each of them, which is setting the text equal to the PDDF sub, the state union territories. And so we can hover over the points and say which place are they. So we'll add that exact same thing in for each of them. Now the histograms have changed to box plots, and they all look very similar. We can see that the box is mostly to the left. On the right are outliers, so there's points like right here, this is the highest active, and here it's actually different, the highest number of total cases. Highest number of deaths is unsurprisingly matched with the highest number of total cases, and highest number of discharged is again not unsurprisingly matched with the number of deaths because it's matched with the number of total cases. Now since we were talking about particular places, we may actually be interested in seeing the values for each of these places, and that can be done in what's called a bar chart. So again, we can copy mostly the same code that's here, except we have to make a couple changes. We're going to change this to bar instead of box. So bar, bar, bar. We're going to change this from X to Y for convenience. Now we're also going to change text to hover text. And we'll see our new graph is exactly the same except they're bar charts. And we can hover over each of the points and see which place they are with the highest number of each. This is a really, really nice graph to look at everything. And don't really worry that this is a 0 and this is a 35 here. It's labeling the index and we don't want to show the name down here. It gets really messy. Now, since the majority of people don't die from COVID-19, what we will see is that total cases and discharge is going to look relatively close to each other. We're going to have 6 million at the top here, 6 million, and all of the pattern here, it's going to look very, very similar because most people do not die. And what we'll see is the pattern looks very similar for deaths if we were to overlay this, except the values are very, very different. They're much smaller. So I'm now going to make what's called a grouped bar chart where we have side by side each of these, the total cases and the discharged, and we'll see just how similar they are. So from above here, we're going to grab our two plots. We have total cases. I'm going to put that down here for now. And discharged, I'm going to put that down there too. Now this is going to look a little bit different than before. We're going to do fig is equal to go.figure. So we're combining them and we're going to give this a list. Now we don't want the names in here now. This is just what they represent. We'll get rid of the variable names and make the first item of the list as that plot and the second item as this plot. And it got kind of confusing, but we need the whole go.bar thing to be the first item and the whole go.bar thing to be the second item as well. And it should line up like this if that's right. We can close the list and close the figure as well. Now we need to tell this that it's grouped, and so we'll do fig.updateLayout and say that bar mode is equal to group. We'll also update the layout to specify that the title is equal to just total and discharged cases. And so fig.show, that shows they're going to be very, very similar to each other, just minor differences, and that is the unfortunate difference of who didn't make it. Also for this one, since it's a little bit bigger of a graph, we can actually specify that x is going to be the same thing here. And so x is equal to the pandas df state UTs. So that shows that on the bottom here, we can have, sorry, just one second, the names of each of them already there, and I have it as you hover as well, you'll see that as well, except you're going to see everything right there. Another graph we haven't quite seen yet is a pie chart, and that is done beautifully in Plotly as well, and we can do it just like the same as above, except a little bit minor changes here. We need to do fig is equal to make subplots again, with rows is 2, and calls is 2. We're going to specify the names of each of the subplots here, and so subplot titles is going to be this list, and that is going to be the same list as we got from the top here. So we grab these items and we can put them in the list there. Now we need to specify this weird thing, and really don't worry too much about it. It's going to be basically a 2x2 set of dictionaries where each of the item is going to be the exact same thing. Each item is just a dictionary that says type, and then it specifies it is domain. This happens to be necessary to make this a subplot of pie charts. So that's the first item, and then we'll copy and paste that, and then we're going to make another list here inside this list. Sorry if you can't really see it that well. Right now is going to look like this. We do this exact same thing. That is good to go. Now again, we can grab mostly the same information as above here. We're going to take all of this stuff and just paste it there, except of course we're going to change this to pi. So pi, 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 and pi. Everywhere we see x, we actually want to change that to something called values. Values, values, values. Name is fine. And we're actually going to change this thing called text to labels. Labels, labels, labels. And our add trace is fine. We are going to do a little bit on the update here. So we're going to keep the update show legend as false, except what we're going to do is update traces, fig.update traces, and we'll change hover info to be the string of % plus label. We're also going to make another update to the traces and make it text position is equal to inside. We have one final thing to do here, and so this isn't really what's called a figure yet. Fig is equal to go.figure of the fig. And then finally fig.show is going to make these very nice 4 pie plots. And yes, you can't really see the smaller values here. We can see the bigger ones, and that's the point. Again, here it takes up 20% here, 31% of deaths, 20% discharge, and active right now 48% there is huge. Now I really want to look at the relationship between deaths and total cases, and so to do that, we are going to make a scatter plot between those two variables. Normally you'd actually use Plotly Express for this, except it's a lot easier for us when we change the graph. What we're going to do is actually add our own linear regression on top of this. So for now, we're going to write it in a little bit of a weird way, but it makes it very easy to extend later. So this is fig is equal to go.figure with the list of go.scatter. We're making a scatter plot with x equal to pddf sub. We're going to choose choose cases to be on the bottom, so total cases. We'll set y equal to PDDF of deaths. And with this type, we need to specify that the mode is going to be markers. Otherwise, we'd see some line that really doesn't make any sense. We're going to do some updates to the layout with title is equal to the string of deaths versus total cases. We'll make the x-axis title equal to total cases and y-axis title to be deaths. And fig.show gave me a slight error there because I have to fix that. And here we go. We have a nice plot here. We can see our huge outlier over there. Now we can see our plot here is beautiful with this outlier. And actually off screen, I just added in text is equal to PDDF state UTs. And what that does is so we can see the name of each of them here. Here's our outliers and here's everything. It still follows a linear pattern very clearly. Now I promised I wouldn't do any deep learning in this, but I am going to do a simple linear regression just to show you, a simple statistical model we can make here. To do this, we generally convert into NumPy arrays, and so here is going to be my input, which we generally do capital X, is going to be on the x-axis here, so that is total cases, and we convert that to NumPy, and Y, my labels, is going to PDDF with deaths to NumPy as well. And so they should have a shape, x.shape, and y.shape should each be 36-dimensional vectors. Now we'll use scikit-learn for this, so we'll do from sklearn.linearModel import linear regression, and we'll set model equal to a blank linear regression. We'll fit the model, and this part's just a little bit tricky because the input is going to not just be x, but it'll be x.reshape with the length of x and then 1, and the reason for that is it's used to multiple linear regression, and so we're going to treat this as multiple linear regression by just extending it to be by 1 instead of by 2 or by 3. And we can just give it the y, and we'll output the model.intercept underscore is the beta naught value, and the model.coef, we can actually just do sub-0 because there's only going to be one of them. And if we output this, we will see it doesn't have this because I need an underscore. And here the intercept value is negative 2466, which makes sense. It's going to be somewhere over here. We could have specified that the intercept is 0, except we're going to keep that. That'll be fine. And here the coefficient with the beta 1 or the slope value is 0.016. So it's not 0, and we will see that this model actually fits it quite well. If we do model.score, we can do the exact same input as above. So I'm just copying and pasting that in, and we see what's called an R-squared value of 0.82. And it's called R-squared because it's actually the squared value of the correlation coefficient. And I'll just prove this to you just for fun, is the value 0.82 here is based off of deaths in total cases from our correlation coefficient, and our correlation coefficient is right here. So deaths and total cases is 0.907. So if I copy this and I bring that all the way down, sorry for the headache, we will see that this value squared is that exact value there, just off by a tiny little bit. Now I'm going to get what's called the fitted values, which just means the prediction for our linear regression based off of the points that it already saw, and that'll make sense shortly if you don't know that, so don't worry about that. We'll do predictions is equal to model.predict with the same information as above except without the y, so we'll just pass it that pasted value right there, and I can see that predictions is this array that should have a shape of, again, 36 predictions for each of the inputs it saw. Now, as I promised before, our graph here I said was easily extendable, so we're just going to copy that and put it down here, except add something to the list here. And so what we're going to add is go.scatter, so another scatter plot, except it's going to be a line this time. With x, the input is going to be PDDF, subtotal cases. The output y, we want to be our predictions, and we'll name this the predicted deaths. And we're going to give our above a name equal to the actual deaths. So that's what it actually was, and the other one was what our line would predict it be. And after running that, we can see here's our points. We have our line drawn through that, our simple linear regression, and that is the end of the project. So congratulations if you've got this far. I hope you learned a lot about PySpark, data visualization in Plotly, SQL, simple linear regression, and just India COVID-19 statistics. Again, a sad topic, but a really, really important one. And I hope you had a great time on this. If you did, please drop a like on the video. It helps a lot. And subscribe to the channel if you didn't get a chance to do that already. Lots of videos, more and more like this are coming out. Let me know what you do want to see, what you didn't like about it. Drop a comment. Let me know, and I'll see you in the next video.